Before anything else, this is not finished. The roads still run through the lake. The stream crosses the track with no bridge, and some houses lead nowhere. It is 6 days old. What matters tonight is not whether the village is finished. It is whether 2 people can be inside it together. This is a multiplayer village game, Day 6, Blender, multiplayer, distribution, and the user feedback loop. These are 2 separate copies of the game on one Mac. The farmer on the left moves through the same village. The player on the right can see. The first architecture choice was simple: 1 player hosts, and that host's village is the truth. Up to 4 guests can join over the local network. 4 pieces, 1 loop. Blender and Godot make the place. 1 host holds the village, and up to 4 guests join that host. Itch.io is how a tester gets the build. F8 is how they tell me what broke. The first real 2 laptop test was supposed to take 20 minutes. It consumed an evening. The firewall was on, but it was not the culprit. macOS stealth mode was silently declining the first knock from the guest that looked exactly like a host that did not exist. Turning off the firewall would also have appeared to fix it, while removing protection the family still needed. The useful fix was 1 setting and an error message that says which layer failed. Act 1 takeaway: 1 player hosts, and that village is the truth. Up to 4 guests can join it. When 2 machines stayed silent, the setting was the problem, not the netcode. Once 2 people could stand here, the next problem was obvious. The place was not worth looking at. My first houses were generated from code, and they looked like boxes with triangles on top. The art direction was blunt. The existing houses sucked. That was enough. The machine could do the production work, but a person still had to decide what was unacceptable. The rule that came out of it is useful beyond this game. If a designer needs to iterate the shape, use Blender. If a programmer needs to iterate the behavior, use Godot. Houses come out of Blender as a model the game loads. The chapel, the shop, and the barn are generated in Godot or on one shared palette. Collision is authored separately either way. The Blender houses introduced a shipping trap. A model that relies on Godot's local import cache can work perfectly on the machine that made it and fail on a clean machine because that cache is not part of the project. So the build gate runs twice, once over the working tree and once over a fresh tracked files copy with no import history. The second pass is the one that proves another person can actually receive the game. AI did not choose that boundary. It built the importer and the checks after the boundary was chosen. Then 1 cottage became a town. 24 buildings from a reusable kit, 4 civic buildings, and 380 conifers around them. The useful detail is not a count. The same town map that places buildings also keeps the forest away from them. A forest drawn in one batch has no individual trees for a collision test to discover later. A town this size also broke the old camera. One distance could show a doorway or a village, but not both. So the view button is a ladder with 3 authored stops: shoulder, normal play, and the whole village. It is a run, not a slider, because every press arrives somewhere known and every screenshot can return to the same framing. Act 2 takeaway: separate art from behavior, test the clean machine, and give players a few good views instead of an ocean of almost good ones. Those 3 fixed views also make the handoff repeatable. Close, play, and village are not lucky. Camera positions anymore, they are places the game can always return to. Then I needed to get the build off this Mac before itch.io. That meant making a giant zip, finding somewhere to send it, explaining what to unpack, and then losing track of which version somebody had. itch.io costs nothing to use for a page and hosted downloads. It gives the project one address, platform-labeled files, and a versioned release history without building a storefront first. This page is deliberately restricted while the game is unfinished. A tester gets the address and a password. That is still much simpler than a USB stick, and it is honest about who the build is for. One release action exports Mac and Windows, labels both with the version printed inside the game, and uploads them to the same page. In 4 days, 6 numbered builds went through that path, from 0.2.0 to 0.2.5. Nobody had to ask which zip was current. Act 3 takeaway. Make release a repeatable path before asking anyone to test. Distribution is part of multiplayer because a game nobody can install has no peers. Distribution creates the next problem. Hearing what broke, friends and children are not going to open an issue tracker, attach logs, identify a build, and reconstruct what they were doing. So feedback starts inside the game. Press F8, and the village asks 2 questions: who are you, and what happened? The report carries 4 useful pieces together: the words, a screenshot of that moment, the current save file, and the last minute of the game's own log. The version travels with them. The screenshot says what the player saw. The save lets me stand in the same village. The log says what the game believed. A sentence that sounded vague now arrives with a reproducible place. The Google Cloud part was not simply put the reports in a database. Sending a report and reading the feedback desk have opposite security needs, so they are 2 surfaces. The game must be able to write without showing a Google login to every tester. The desk must not be readable by everybody holding the game. Combining those jobs would make one side unusable or the other side public. The right side runs on App Engine Standard. It accepts HTTPS from the build, checks a shared secret, limits the size, and stores the bundle. That secret filters casual junk. It is not a player account and should not be mistaken for one. The read side runs on Cloud Run behind Google's identity-aware proxy. Opening the desk requires my Google identity. No desk password is shipped inside the game, and a tester never needs access to the list. Both sides use the same small Go service. One deployment is told to receive, the other is told to display. That keeps the report format from drifting while preserving the security boundary. The split exists because identity protection on this App Engine setup covers the whole application. Putting it in front of the receiver would also put a login screen in front of the game. 2 deployments are less clever and more correct. For a closed playtest, the shared secret is an acceptable first gate. For a public game, it would not be enough. Somebody can extract a secret from a client, so public scale brings accounts, abuse controls, and a different cost. At this playtest traffic, both services sit inside Google's free allowances, so the expected bill is approximately 0. That is a current operating point, not a forever promise. Billing alerts and the console still belong in the release checklist. That server mattered immediately. A player who was not me reported that a door opened and still would not let them through. The door was working, its leaf moved, its blocker dropped, and the wall behind it was still solid. Every automated check passed because every check was asking about the door. A green test suite proves what you thought of. A player proves what you did not. That is why the feedback desk took longer than the netcode and why it belongs inside the multiplayer story.